Hello, my name is Mr. Bakri Dasuki, physics teacher in Cambridge International School, Kurdistan. So today I'm lesson for the students who are in level IGCSE 2 and we're gonna take unit 10 electrons and electronics. So when we hear electrons or electronics, that means our mind related to the circuits, okay? So each electronic circuit exists in any device. For example, your mobile now that you use, or your laptop, or your PC, or any other device, you'll find there's what electronic circuits. So the electronic circuit, it's organized all these devices and lay out on the supply, they control the supply, how it show, and a lot of other things. So today we're just gonna take the electronic essentials. So for example, we have here man talking. So this man make sound, right? So the sound it make give the microphone small changes in the current. The microphone can feel these changes in the current and send it to the amplifier. The amplifier, of course, it gets power, and the amplifier it makes the voice what is much, and it's amplified. That means make it more magnificent or more higher. Loudspeaker, it will come out from the amplifier and make loud voice. So if you're hearing my voice on a speaker, you'll find is my voice what it's much higher than it's in the fan. Why? Because in the speakers you have amplifiers. Okay? Let's go to the flow diagram. We have here the microphone is what is input sensor, and then it goes to the processor. Of course, the processor also have a power, and they have output device. So when we have two types of signals, so the small changes in the current here is called signals. Okay, we have analog signals and digital signals. The analog signals is something changing. Okay, for example, here we have an analog wave. So in each time, it has what different value. Okay. The digital signals, it's even 1 or 0. 1 or 0. Okay? So even 1 or 0. 1 or 0. 1, 0, minus 1. And etc. So we say the analog is what is changeable. It's not just even 1 or 0, like we see in this example. The digital, like we see there's digital watches, so you can see the time, they give you the time, what, for example, and you see it's like this, right? And the one is like 2. For example, this 12 and let's say 30 minutes. So if you check the digital, there's a lot small spaces between the numbers. So why is that? Because each one have different length, okay? Different light, let's say, and will go up or will go and show us the numbers by, of course, an electronic signals. So you can see here, open your book, page 228. You can see here the digital watch. You see it? Also here you can see the IC or integrated circuit we'll talk about now. You can see it here, page 228. So We talked about the input sensor and the processor and the output device. So everything, even if it's digital or it's analog, we have sensors or input, something it gives us, okay? Give us the current changes. Then the processor will control and decide how it will go out to the output devices. So the output devices like this loudspeaker will say, it got the amplifier or the microphone will send the inside and the amplifier will make it bigger. We'll decide how much bigger, the processor, and it will go out. The output, it will be the loud voice. So when you look on page 228, you're gonna see this list of components. First we have resistors. So resistors, they keep what? They keep the voltage and the current stable in the circuits. Okay? So it does make it change. Then we have capacitors. The capacitors is just like a small battery. Here's the resistor. It's even like this. Or it's in the middle. Or like this. The capacitor symbol and the one who have negative and positive is like this. Now the diodes. So what's we were talking about the capacitors. The capacitor's job is just like a small battery. It stores the charge and it's empty of course to the circuit when it's needed. The diodes are what? Giving, this is the symbol of the diode. The diode is let the current go in one direction and it block it in other direction. For example, I need this electricity just come from here but don't come from the same way. So I want it to go and don't come. Okay? So let's say it's just like direction organizer. And the symbol works. Then we have light emitting diodes and there are LED or LEDs. So it's the same symbol but we have light. So when it has small current, this diode will have light. You can see it in a lot of things like even the remote control or anything, the charger and the light. Even your normal electricity next to the plug, you'll find this red light, this is LED. Then we have the transistor. The transistors, they have two jobs. At first, even it's amplifier or it's switch on and off. Integrated circuits, IC or microchips, we saw it here in page 228. This with a lot of pins. So the pin, each, for example, this element has 2 pins, okay? So the microchips or the integrated circuits or the IC, as known, so they have a lot of complete circuit from diodes and resistors and capacitors, and usually it's made from silicon, okay? Crystal silicon, of course, it's treated differently and in a special way it's made. The last thing we're gonna talk about 10.1 is the relay. The relay is like a switch. So, but it works in electromagnet. So remember the electromagnet, right? So it says when we have something like metal bar, and you have here this copper wire, and we apply electricity or give it power, this will be a magnet, right? You remember that. So what's happening here, the relay, it has what? Switches. For example, this simple one. So when it moves, Let me try this side so you understand. So this one is closed, okay? It's here, but I want you to see what I mean. Usually we draw the switch like this, but I stick it so you understand the physical thing. So when I apply electricity here, what's happening? There will be magnetic here, okay? And this magnetic will pull this switch. So this will close. It will contact for the pins that are the wires connected to, and this will be what, when it pulls, it will be open. That means it will be close to the circuit. Okay? So similar to that, when this have a magnetic, when it have magnetic, when I apply electricity. So this normally closed, normally it's like this, and this normally open. In the normal way, without electricity, it's like this. When I apply electricity, the open will be closed and the close will be open. So when it's closed, that means it gives us the current or the electricity, and when it's open, it don't. So you see there is two switches here. There's relay with 1, there's a relay with 2, there's a relay with 3, 4, etc. So let's take just some examples for the output and input devices. Input sensors in page 228. Pressure switch. This means it's a switch applying on the pressure. For example, you see this slide. It's a switch. Okay? It's input. Even make it work, turn on or turn off. Reed switch is switch operated by a magnet. It can feel the magnet. Switch, that means even it's on or off. Variable resistor is also input, so it's changed the value. For example, like the speaker you have, you will find this. You turn it, the voice will be even higher or lower, right? So from this, it's you changing the resistor value. Okay. Thermistor is for temperature, or what does it mean? Temperature dependent resistor. So it's changed with the temperature. LDR is light dependent resistor. So it's will fill the light. The value will be what? Very low, and it's dark. The value of resistor will be very high. Microphones, as we see here, it's feel the small changes of the voice, and the amplifier or loudspeaker. For the out devices, for as example LED or LED, we take the light imaging diode, and this for what? It's for just give us signals. This is working, this is not working. Normal lamp, buzzer that makes sounds. Like for example, when you turn on your AC and this will give you this ting, this is the buzzer. Loudspeaker, we took example like here. Relay, so it's an output because it's what after the torque, even it's connect or disconnect. Electric heater as the water heater or the normal heater. Electric bell, electric motor. All this you can find out in your daily life.